Hey students, are you ready to explore the fascinating world of differential equations? They might sound complicated, but they're actually incredibly useful for understanding how things change around us. So, what exactly are differential equations? Simply put, they are equations that involve the derivatives of a function. This is super important for your CBSE exams, and you can expect to see around 5 to 7 marks dedicated to this chapter. So, let's get started. Let's start with the basics, order and degree. The order of a differential equation is simply the highest derivative present in the equation. The degree is the power of that highest order derivative. Understanding these helps us classify different kinds of equations. Okay, so what does order really mean? The order of a differential equation tells you how many times the function has been differentiated. A higher order indicates a more complex rate of change being modeled. Think of it like this: a first-order equation describes speed, while a second-order equation describes acceleration. Now, let's talk about solving these equations. There are a few common methods. Separation of variables is where you rearrange the equation to isolate the variables and then integrate. Homogeneous equations use substitutions like y equals vx. And linear equations require an integrating factor. The integrating factor is your best friend when solving linear differential equations. The formula is e raised to the integral of p dx, where p is the coefficient of y in the linear equation. You use this to solve equations in the form dy, dx plus py equals q. Let's dive a bit deeper into homogeneous differential equations. These equations have a special property: all their terms have the same degree. To solve them, we use the substitution y equals vx. This substitution magically transforms the equation into a separable form, which we already know how to solve. Now, about the degree of differential equations. The degree is the power of the highest order derivative, but only if the equation is a polynomial in its derivatives. So, if you see something like dy, dx, squared plus y equals x, the degree is 2. Remember, it has to be a polynomial. Here's a key point that many students miss: always check if the equation is a polynomial in its derivatives before determining the degree. Examiners love to trick you with non-polynomial equations. If it's not a polynomial, you might need to rationalize it first. Let's tackle an example. Suppose we need to solve dy, dx equals x plus y, divided by x minus y. This is a homogeneous equation. Step 1. Substitute y equals vx, which means dy, dx equals v plus x times dv, dx. Step 2. Separate the variables, integrate, and you'll find the solution is ln x squared plus y squared equals c. Did you know differential equations are used to model real-world phenomena? Take Newton's law of cooling, for instance. It states that the rate of temperature change is proportional to the difference between an object's temperature and its surroundings. This is a classic example you'll see in your CBSE problems. Here are some exam tips to keep in mind. First, always find the general solution first, and then use the initial conditions to find the specific solution. Second, identify the type of equation before you start solving. And third, double-check your integration and substitution steps. These steps will help you avoid silly mistakes. Let's quickly summarize what we've learned. Differential equations model real-world change. The solving methods depend on the type of equation you're dealing with. And remember, initial conditions are crucial for finding specific solutions. Keep these in mind for your exam. Guess what? All of this, AI notes, doubt solving, practice tests for differential equations, is available to you for free on Synapse. We're here to help you study smarter, not harder. Download the app and get started today. Ready to master differential equations for your CBSE exams? Start free today at synapse.omups.in. And don't forget to subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.